Hello and welcome to Unit 2, Lecture 3 for Introduction to Logic. We're still doing derivations today. Today we're going to learn a new kind of derivation called a conditional derivation. Conditional derivation is a method for proving conditional statements that we can't use for any other kind of statement. And the reason we need this is that for all the other connectives, for the wedge, the ampersand, the two-way arrow, we have both an in rule and an out rule. And we use the in rule for proving things of a certain form. How do you prove an arrow statement, though? There's no arrow in rule. Instead of arrow in, we're going to learn this technique called conditional derivation. And the idea is that if you're trying to prove an if-then statement, how would you prove that if something is true, then something else is true? Well, you do it by assuming that the if part's true. Assuming that this is true, we can show this other thing. So the technique is to assume something and then show something else. To show that A arrow B, you assume A and then you show B. Now I'm going to scroll past some text here. This is the same thing I'm about to go over in this problem here, but it's easier to follow if you actually see it in an actual problem. So suppose we're doing this problem. P arrow Q, Q arrow R, show P arrow R. There's no way to do this using the rules we've learned so far. There's no way to do this using direct derivation. We're going to learn a new technique, conditional derivation. So over in this box over on the right, I'm going to write CD rather than DD for conditional derivation. Conditional derivation works like this. You put in a new line to assume the if part of what you're trying to show. We're trying to show that if P were true, R would be true. We're going to temporarily assume that P is true. So you write P in this box here, and over on the right, you write ASS for assumption. We're assuming that P is true. We don't actually know that P is true, but we're going to show that if you assume that P is true, you can show that R is true. And the next line you want isn't a normal line, it's a show line. We want to demonstrate that if we assume that P, we can show that R. So we have a new show line. You click the new show line button to get a new show line for R. And we're going to show that R using our other rules, using our direct derivation rules. So this one's going to be by direct derivation. So now we're going to use the rules we had before to show that if we assume that P, we can show that R. And we're doing a proof within a proof here, a show line within a show line. So you see there are dotted lines for there's going to be a box within a box. This box is a box in which we show that R. Once you have a new show line, you should concentrate on showing the new show line. But we can use the assumption we assumed it for along with 1 and 2, the premises. If P then Q, we have P at line 4, we get Q. So that's 1 and 4 modus ponens arrow out. Now that we have Q then R at line 2, so we get R from 2 and 6 modus ponens. So that's demonstrating that R. We've shown that R. Once we've shown that R, we can cross off this show line by clicking the word show there and draw that box. The way conditional derivation works, rather than demonstrating P arrow R directly, you assume that P, you show that R. If you succeed in showing that R, you're allowed to cross off this show line as well. So you can cross off the show line for the conditional derivation if you assume the if part and succeed in showing the then part. So if you have a box within your box where you show the then part by assuming the if part, you're allowed to cross off the show line for the conditional as well. That's the idea behind conditional derivation. Let's do another one. You can only use conditional derivation if the main line of the show line is an arrow. So here we have a premise, P arrow not Q. It doesn't matter that the premise has an arrow in it. The important thing is this, the main operator of the show line is an arrow. Here the show line is show if Q and R, then S or not P. So we're going to do this by conditional derivation. The way conditional derivation works, first you have a new line which you assume the entire if part of the if then. So we'll assume Q and R. That's our assumption, ASS for assumption. Then the next thing you have isn't a new regular line, it's a new show line. So I'll click the new show line button. We're going to show that S or not P. And we'll show that by direct derivation. Using the assumption line 3 along with our premise at line 1. So we'll start out by breaking up line 3 as an AND statement. Usually when you get an AND statement as a premise or assumption, you want to break it up using ampersand out. So we get Q in one line, R in another line. We don't actually need the R, but I'm going to go ahead and do it anyway, just because it's a good habit to break out both sides. And we don't care if you do extra. You can do extra steps. We don't take off for that. All right, so we want to use line 1. We need either the if part or the negation of the then part. We don't have the negation of the then part, but we do have Q. If we double negate Q, we'll get not Q. And that's the negation of the then part of 1. So now we can use line 1 with modus tollens. 1 and 7 gives us not P. And we're trying to get S or not P. Once you have half an or statement, you get the whole or statement by wedge in. So by wedge in on line 8, I get S or not P. So now I can cross out this show line. And the way conditional derivation works, if you cross out the show line below, if you assume the if part of the if then, and you succeed in showing the then part, you've shown this as well. So we can cross out that. Check our derivation. And that's how that works. So let's do one more here. You use conditional derivation pretty much whenever the show line's main operator is the arrow. And the show line's main operator is the arrow, you're going to do that by CD for conditional derivation. First, you click new line to put in the assumption, then a new show line to show the then part. We will show the then part by direct derivation. So not H gives us E from line 2, either H or E. We have not H, so we get E by 2 and 4 wedge out, right? Either this or that, but not this, we get that. If E, then G from line 1, we turn that two-way arrow to a one-way arrow. It makes sense to turn it into this one-way arrow because we have E, we're trying to get G. So now we get G from 6 and 7. And then you put the G and E together to get G and E. So we can put the G and the E together that we have on separate lines. That's 6 and 8 ampersand in. So now we've shown G and E. We can cross off this show line. The way conditional derivation works, if we cross off the show line below, you can cross off the show line above. All right? Another thing you can do is you can do a conditional derivation within a conditional derivation if the new show line is another conditional. So let's see how that works for this problem. The main operator here is this arrow. So when the main operator is the arrow, you do it by conditional derivation. You assume the main operator of the if part of the main operator, and the new show line is the then part of the main operator. But if the new show line is another conditional, we can do another conditional derivation for this show line, right? So now we're trying to show if not B, then C. We don't have to show that by direct derivation. We can show it by conditional derivation. So we'll do another conditional derivation, put in a new line. We'll assume the if part of this if then, a new show line for the then part of this if then. So we have a box within a box within a box. We'll do this one by direct derivation. We can't do another conditional derivation because that's not an arrow statement. So now we can use either of our assumptions. We can use the assumption at line 4, we can use the assumption at line 6. So we have A, we have if A then D, we get D from 1 and 4, arrow out. To use line 2, we need D and not B on a line by itself. We have D and not B on separate lines. Let's put them on a line together. So we have D at line 8, not B at line 6. So we put those two together by ampersand in, we get D and not B. Then we can use line 2 and we get C. If D and not B, then C. So 2 and 9, arrow out, gives us C. Now we've shown C. So if you're doing a conditional derivation, if you assume the if part of your if then and show the then part, you've shown that if then. You assume the if part and show the then part, you've shown that. So we've done all of this now. You can do a conditional derivation within another conditional derivation. This problem here also works like that, where you do a conditional derivation within a conditional derivation. I'm going to skip over that because I'm trying to keep these lectures short. You can try that one for yourself. Pretty much use conditional derivation whenever you want to prove an if-then. Now, it could be that the if-then you're trying to prove isn't the main conclusion of the argument. It could be that you're trying to show an if-then on another line, and you want to use conditional derivation for that. Let's show how that works. So that's a little bit different. So let's look at this problem. If P, then P or Q, then R, show R. Now we can't do this by conditional derivation at this show line because the main operator of this is not an arrow. So we have to do this by direct derivation. So what do we do here? How do we show this? We have to use line 1, but we need P arrow P or Q. Now you're allowed to put in show lines whenever you want. It'd be nice if we could show this here. It'd be nice if we could show if P, then P or Q. And the way you show an arrow statement, since there's no arrow in rule, is by conditional derivation, but we need a show line whose main operator is an arrow. Now you can put in a show line whenever you want. So I'm going to put in a show line, click new show line, to show P arrow P or Q. Because if I can show that, then I can use line 1 to show R. This one I can show by conditional derivation since it's conditional. You assume that P, new show line to show P or Q. Notice that this here is a tautology. We have P, we get P or Q just from line 4 by wedge in. You have half an or statement, you get the whole or statement. So we've shown P or Q, therefore we've shown this by conditional derivation. Now all the stuff in this box here that I've crossed out, this is all showing that P arrow P or Q by assuming that P. I can't use anything. Once I've drawn a box around something, I can't use that. And I can't cross out the show line at line 2 yet. Because to cross out the show line at line 2, since it's by direct derivation, I actually have to get R in the box. But once I've crossed off the word show on a show line, I can use that show line. So notice that line 3 is a show line, but the word show is crossed off. I've shown that now. Now that I've shown that, I know that it's true. That's not inside a box. The word show is crossed off. If you cross off the word show on a show line, and it's not inside a box, you can use that show line. So we can use line 1 with line 3 now. I can use line 3 since the word show is crossed off, and I get R from 1 and 3 arrow out. Now I've shown that R. So if there's an arrow statement you want to show, you don't have a show line for it, you can put in a show line for it. That's how you show an arrow statement, is by conditional derivation, but you need a show line that has that arrow statement. You can write in show lines whenever you want. Whenever you want to show something, write in the show line to show it. And once you show it, cross out the word show, you can use it. You have to draw a box around the lines you used to show it, and you can't use those lines anymore. Once you draw a box around something, you're not allowed to use those lines anymore. You can use the show line with the word show crossed off. And this is important for showing two-way arrow statements. If you're trying to show a two-way arrow statement, you need 2 arrow statements, 1 in each direction. So usually the way you do that is by 2 conditional derivations, 1 in each direction. So let's see how that works in an actual problem. Not B and C. Show if either A or B, if and only if A. We're going to do this by direct derivation. And we can't do this by conditional derivation. We can only use conditional derivation when the main operator is the one-way arrow. This is a two-way arrow. But what we want is we want each of the one-way arrows. So the next thing I'm going to do is put in not a regular line. I'm going to put in a show line. I'm going to show the one-way arrow in this direction. Show if B, then A or B, then A by conditional derivation. When I'm done showing that, I'll go and do another conditional derivation to show the if then in the other direction. But first we'll show this if then. Now this is a conditional derivation. You start by assuming the if part, new show line for the then part. But that will be direct derivation since that's not a conditional. I have not B at line 1. Break that up. A or B, but not B. I get A from 4 and 6. Now I've shown that A, and I've shown this by conditional derivation. When you're doing conditional derivation, if you cross out the show line below, you can cross out this show line. Can't cross out the show line at line 2 because that's direct derivation. I need this exact statement inside the box. I only have it in one direction. I'm going to put in a new show line to show the if then in the other direction. Because once I show that, I'll have the if then in both directions. I can do this by conditional derivation. Assume that A, new show line to show A or B. That's direct derivation since that's not a conditional, but I get A or B right away from line 9, I can't use the A or B at line 4 because it's inside a box. You can't use any of these lines that are inside this box here. But I can use line 9, get A or B by wedge in. So I've shown A or B, therefore I've shown this. Now notice that lines 3 and lines 8, the word show is crossed off, and they're not inside boxes. I can't use these lines here that I used to show them, but I can use these lines that I've shown. So I've shown the if-then in one direction, I've shown the if-then in the other direction. So the last step is to get A or B, double arrow A, from double arrow in on those two show lines that are crossed off. So I can use those lines, not the word show is crossed off, double arrow in. So I've shown that, and there we go. I'll do one more like that. So R if and only if Q, Q if and only if P, show P if and only if R. So whenever you're trying to show a two-way arrow statement, by the show line for the two-way arrow statement, write direct derivation, but the next step is to put in a new show line to show one of the directions of the two-way arrow. And that you show by conditional derivation. So first we'll show P arrow R. When we're done showing P arrow R, we'll come back and show R arrow P. So we'll assume P, and then show R. So we have P, we're trying to get R, so we need P arrow Q from line 2. Double arrow out, we can change the two-way arrow to a one-way or another direction. We want P arrow Q because we have P, we're trying to get Q. So we get Q from that, 5 and 7 modus ponens. Now we need Q arrow R from line 1. We can get the if-then either direction, so that's 1 double arrow out. Then we get R from 8 to 9 modus ponens. So now we've shown R, and therefore we've shown P arrow R by conditional derivation. We want to show R arrow P as well. So use show line to show R arrow P. We'll do this by conditional derivation. Assume R, show P. That's direct derivation. So we have R arrow Q from line 1. Change the two-way arrow to a one-way arrow. So we have R, we get Q. We can't use the stuff inside a box here, but we can use the lines 12. We can use the premise at line 1 that's not inside a box. So we get R arrow Q, we get Q from 12 and 14. We get Q arrow P from line 2, double arrow out. Then we get P from 15 and 16 modus ponens. Now we've shown P, we've shown R arrow P. But to cross off the show line at line 3, we need this exact statement here. But we crossed off the show lines at line 4 and line 11. Now that we crossed those off, we can use that, and we get P double arrow R. The two lines you cite are the two crossed off show lines that aren't inside boxes. That's 4 and 11. Double arrow in. So now we have shown P double arrow R. We can check our derivation. There we go. So use conditional derivations for showing conditional statements. And we use two conditional derivations for showing two double arrow statements by putting in a show line for each of the two directions, then using double arrow in at the end. There's a special rule called R for repetition that we need if there's a line you already have and you need to get it inside the box for a conditional derivation. That's not needed very often. Let's see how that works in this problem. A, show if B, then A. We do this by conditional derivations. It's conditional. We assume B, use show line to show A. But how do we show A? We already have A. We already have something, but we need to get it inside the box for show A in order to cross off the show line. You can repeat a line you already have inside the box you need it to be have. We already have A at line 1. So we just write the line number we're repeating, R for repetition, and you write R for repetition. So we're repeating that. The only point of doing that is to get A inside the box to cross off this show line here. Now we can cross off this show line, we can cross off this one by conditional derivation. So there's a special rule you don't need very often called R for repeating things. All right, so that's it for today. We'll do indirect derivation next time.